Okay, so now let's take a look at some of the requirements for human life. Remember from your reading, oxygen and water are critical for survival. Oxygen is necessary in order to fully complete cellular respiration. So remember that from bio, hopefully. And water is critically important because it is a substance that all the chemical reactions need in order to be completed within your body. Okay? So we have a very narrow tolerance for temperature regulation in the body because temperature regulation and water regulation are very, very closely related. So let's take a look at temperature. There are 4 ways we can lose heat within the body. 4 ways your temperature can drop. They are evaporation, convection, conduction, and radiation. We're going to take a look at each of those separately. Okay. So first of all, evaporation. If you took physical science, this graph here should be very familiar to you. Okay, if you didn't, that's okay. I'm going through it now. So on the x-axis here we have time, and on the y-axis here we have temperature in Celsius. So basically we're starting off with solid ice and a block of solid ice at time 0, and we're adding some heat to it. So that solid ice is warming up, warming up, warming up, and then we're going to get to a dotted line here, and this is going to be 0 degrees Celsius, in which the ice starts to melt. So now this dotted line represents a plateau, represents a phase change, and we're going from solid ice to liquid water, and it's a mixture. At this point right here, we now have all water, all liquid water, and that water is now heating up, getting warmer, 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 until we reach 100 degrees Celsius. That water will then start to boil, and here we have another plateau, which is a phase change, and the water will then boil, and it will go from liquid to gas. And at a certain point right here, we have reached the point where all your water has boiled away, and now we have water vapor, or a gas. Okay, so we call that evaporation, when you're going from liquid water to gaseous vapor. So in order for water to evaporate, you need to add heat. Now, it doesn't necessarily mean that you need to boil yourself. You simply take some water on you, like, oh, I don't know, sweat, and you let it cool off, and that sweat will evaporate off you, and you're hopefully not boiling, and it's going from liquid water to gaseous vapor. Now, the cool thing about this is that, speaking of sweat, if this is sweat, the heat that your body is obtaining to evaporate that sweat is coming from your own body. So think about it. If you're using the heat that is coming off of your body to evaporate the sweat that's on your skin to go from liquid to gas, your sweat's evaporating, and you're using heat from the body, what do you think is going to happen to your body temperature? It's going to drop. And that's why it's necessary not only for you to sweat when you're starting to overheat. That's not the important part. The important part is allowing that sweat to evaporate, to go from a liquid form to a gaseous vapor form. Okay, let me show you. This next slide here, on the left-hand side, this figure right here is showing a sweat gland producing sweat. And as long as the sweat ends up on your skin and can evaporate off your skin, you're going to lose heat. Okay? Now take a look over here on the right. This brown figure that we have over here on your screen. There are 2 environments. There's a very humid environment on the left and a less humid environment on the right. So I'm not a big fan of summer. Okay? I hate bugs, I hate heat, and I hate humidity. Humidity is the key here. So when you live in a very humid or work in a very humid environment, there's so much moisture all the way in the air. Yes, you're going to be out there sweating when you're cutting the grass or doing yard work or playing basketball or something. You are going to sweat. But the thing is, that sweat is simply going to run off you, drip off you, and you're wasting that water. You're losing water, but you're not allowing that sweat to evaporate off you, which means that you're not cooling down. Now, if you look on the right-hand side, in a very dry environment, like I've never been out west, but it sounds like Arizona is a very hot but very dry environment. So here you are cutting the grass now out in Arizona. Yeah, it's hot. Yeah, you're sweating, but there's very little humidity. There's very little water vapor in the atmosphere. So that sweat is allowed to evaporate off your skin, and it's using the heat that your body's producing to evaporate that sweat, and your body temperature is dropping back down to normal. Okay? So if you have the choice of working in a humid environment or a dry environment, work in a dry environment because your sweating is going to be more effective. Okay? Okay. Another way of heat loss is convection. Convection is using a fluid current going by the body to take away heat. So you could fan yourself. Whew, man, it's hot here. Okay? That's air is considered a fluid. That air is passing by my body, pulling heat away. Another way you can lose heat by convection is by swimming. So being in water, that water going by your body, water is a fluid, will take away some heat as well. Another way of heat loss is conduction. So this is putting an ice pack on you. It's direct contact. It's the reason why if you sit, if it's a cold Friday night and you're watching a football game and you're sitting on the metal bleachers, very, very cold, you will lose heat going from your body going to the bleachers. Heat always moves from high heat to low heat. It never moves from low heat to high heat. Okay? And lastly, radiation. Radiation is the reason, I put my coffee cup away, travel mugs have lids on them. You can't see the heat loss, but you're physically losing heat in the form of radiation. Not bad radiation. It's not the kind of radiation you get from like a nuclear reactor or something. It's called radiation. I am radiating heat right now. If you took a heat gun to me, not a heat gun to melt, but like an infrared, forward-looking infrared. If you took a thermal imaging camera, that's what I'm looking for, just like this picture here, you'd be able to see the heat coming off of my body. Okay? And lastly, this diagram shows you all the different kinds of heat losses in one diagram.